Point mutations arise when one base in the nucleotide sequence is swapped with another. Transitions happen when a purine is swapped with another purine or a pyrimidine is swapped with another pyrimidine. Transversions happen when purines are swapped with pyrimidines or when pyrimidines are swapped with purines. There are 4 types of point mutations. The first one I'll go over is the missense mutation. Missense mutations occur when the changed base results in a different amino acid. Before we go over an example, this is the coding strand of our normal sequence we'll be using to display the mutations. This is the corresponding mRNA sequence, and this is the corresponding sequence of amino acids that will form our protein. For now, we'll get rid of the coding strand and focus only on the mRNA and protein. In this example, we're going to swap this guanine with an adenine, which will result in the cysteine amino acid becoming a tyrosine. Since we swapped a purine for a purine, this mutation was a transition. This new amino acid can have several different results. First off, it may not have an effect on the function of the protein at all. It may slightly alter the protein's function, or it might even make the protein non-functional. The second type of point mutation is the nonsense mutation, which occurs when the base swap results in a new stop codon. For this example, we're going to be using the same normal strand, but this time we'll swap this guanine with an adenine. We swapped a purine for a purine again in this example, which means this would be classified as a transition. This change gives us a new stop codon much earlier in the sequence than previously, which will almost certainly produce a protein with a different function or no function at all. The third type of point mutation is the silent mutation, which occurs when the base swap results in the same amino acid. For this example, we're going to make a pyrimidine to pyrimidine transition by swapping this uracil with a cytosine. This change gives us another alanine amino acid where there already was one. This mutation will result in no change to the protein's function because we're swapping the same amino acid for itself. The final type of point mutation is the read-through mutation, which occurs when the base swap changes a stop codon into one that actually codes for an amino acid. For this example, we're going to make a purine to pyrimidine transversion by swapping this guanine with a uracil. The effects of this change would be drastic because the protein would become longer as a result of the sequence not having stop codon until the end of the next protein sequence. The additional length would likely lead to a non-functional protein as the sequences of 2 proteins will be combined, distorting the protein shape.